so this first section on the review, we certainly have some formulas that you may want to have in like several places ready to go for tomorrow's assessment. And this is something that we took notes on the day you weren't here. So make sure you have these down. We have the sum of the interior angles in a polygon. That formula is n minus 2 times 180. I'm just going to get a calculator for when we do this. You can use a calculator tomorrow. The thing is, we can provide them, like if you need them, but we have to like, I don't know, like probably has to sit for like a solid month before we can reuse them. So if you have a calculator, bring it over like not a cell phone, but like a calculator. If you have it, bring it. That way we don't eventually run out of having ones that we're able to use if you have one at home. So we have the sum of our interior angles. We have each, so when it asks for each angle versus the sum interior angle, we have this formula, which is our sum, and then we just divide it by the number of sides that we have. And so if you haven't watched these notes, you're going to feel a little lost right now. Well, I'll try to do my best to kind of recap as we go through it. But you're going to want these formulas. The sum of our exterior angles is absolutely the easiest, but the one that students make the most mistake on because it's not a formula at all. The sum of the exterior angles always adds up to 360. And then we use that fact, really not a formula, to find each exterior angle in a polygon by taking 360 and dividing it by the number of sides in that polygon. So there's my list of formulas I would want for this section on our test. And so what we are talking about here are different polygons. So for example, it says a regular convex hexagon. A hexagon is a polygon with how many sides? Hexagon. No, pentagon is 5, 6, yeah. So what I need to be able to do from this, and it is in our notes, is know how many sides, when I see those words, I need to know what n is, and n is the number of sides. So a hexagon, regular convex hexagon, that means our regular hexagon that we see like in a children's puzzle where all of our sides are the same length and we have 6 sides around that polygon. And what it's asking for is what is the angle measurement for each of these angles. And because all of my sides are the same, I'm dividing my angles equally. So it's going to be the same angle measurement for each interior angle. And we use our formula, and on the notes, we broke down why this formula is what it is. So if you haven't watched the notes yet, you would want to do that. But we kind of derived this formula given how many triangles are inside each shape. And so a triangle totals 180, and we always had 2 less triangles than the number of sides. Okay, that's how we got the formula, but we can just use it now that we found it. So if n is 6, and we know we're talking about each interior angle here, we know that we're using this formula, n minus 2 times 180 divided by n, and I'm going to plug in 6. So 6 minus 2 times 180 over 6. Okay, all I'm doing is plugging in 6 for the number of sides. 6 minus 2 gives me 4. 4 times 180 is 720. Divided by 6 gives me and out of space, 120 degrees for each interior angle. So these problems really, given that it's an open notes quiz, should be gimmies, right? Like you have the formula. All you need to be able to do is say, how many sides do I have, and plug it into the formula. Okay. Make sure you don't type this all in. I guess it probably shouldn't make a difference because it'll multiply and then divide. Sometimes, depending on the order of operations, you don't want to type in like the entire thing. When I have a fraction, you may want to figure out what the numerator is and then divide by 6. Depends on what calculator you have, if it'll correctly follow order of operations or not. So on the second one, it says the sum of the interior angles. So different formula. The first one was find each. This one is just find the sum. So the sum of the interior angles, n minus 2 times 180 is the formula we want. Of a regular nonagon, how many sides does a nonagon have? 9. So I need to be able to, from this, know that I'm using n equals 9. I'm just going to plug that into my formula. So 9 minus 2 times 180 is what I'll do, or 7 times 180, which gives me 1260. What this one is asking is all of them. So here I was only finding one angle. We are finding the total. If I add all my angles up in a 9-sided polygon, I'd have 1,260 degrees. Number 3, it says each exterior. What is my formula to find each exterior? 360 divided by n. So for each exterior angle, when I'm asked that, I know I'm using this formula and I'm looking at an octagon. How many sides does an octagon have? 8 sides. So I have 360 divided by 8 gives me 45 degrees for each exterior angle in my octagon. So what we're finding with our exterior angles, I think from an octagon, 2, 3, 4, 5. There's our octagon. When we're finding each exterior angle, what we're finding is if I was to extend a line out, here's my interior angle, here's my exterior angle, just to get a concept of what degree we're finding. So that's 45 degrees, and then all the way around, I could extend all of these sides. Okay, all the way around that shape, and they'd all be 45 degrees, and it would add up to 360 around the outside of the shape. Okay. Number 4, it asks for each interior angle. What is my formula for each interior angle? Each interior. No, yell at once.
N minus 2 180 over n.
N minus 2 times 180 over n. And it says a decagon. How many sides does a decagon have? 10 sides. So I'm going to substitute in 10 minus 2 times 180 over 10. 10 minus 2 is 8. 8 times 180 gives me 1,440 over 10, or dividing that by 10. Each interior angle in my decagon, you should have had 144 degrees. Easiest question on the page. The sum of the exterior angles of a 14 gun. What is the sum of the exterior angles of a 14 gun? 360. What is the sum of the exterior angles of an octagon? 360. What is the sum of the exterior angles of a 25 gun? 360. Okay, so anytime it says the sum and its exterior angles, I just answer with, well, the sum of the exterior angles always have to add up to 360. I'm done. No math involved. I just know the answer to that. It's like a trivia question. Yeah.
If you forget the degree sign, is that points off?
I won't take points off if you don't write the degree sign. Each exterior angle, so not the sum, but each, we would do 360 and divided by our number of sides. And this time it just tells us a 16 gon. So instead of having like a special name like hexagon, octagon, decagon, we're just told that this has 16 sides. Okay, that's what that means. 16 gon means I have a 16-sided figure. So I take the 360 and I divide it by 16, gives me 22.5 degrees. That one is a decimal. Now, number 7 just words it differently. So you notice like on the rest of them, most of the time it was like, well, I guess it's, well, no, it's worded differently. Okay, it's like each or the sum or each or the sum. And this one just puts it here. So it says the interior angle sum. So it's just worded a little differently. Same formula, interior angle sum means we're just doing n minus 2 times 180 of a pentagon. How many sides does a pentagon have? 5. You weren't in class last week when I shared that I have a friend whose son loves pentagons and went as a pentagon for Halloween. I may have shared that in algebra last year too. Like, it's the funniest thing to me. They just cut out a cardboard pentagon and that's what he went as for Halloween. Little pentagon. N minus 2 would give me 3 times 180, gives me 540. Now, the last one is the trickiest one here because it doesn't give you the polygon. What it gives you is so it says each interior angle, that's this formula, equals 120. What it doesn't give you is the actual name of the polygon or what n is, right? So this is saying we need to find what n is. It's definitely the most challenging question on this page. And so there's a few ways I can go about this. I could see kind of 2 lines of thought here. So one would be to use inverse operations and solve the equation as we do in algebra class all the time, but it's kind of funny because the variable's here. So one way that I could start this is to multiply by n on both sides just to get rid of the fraction. And then I can also distribute the 180 at the same time. Okay, so then I would write, okay, I have 180n subtract 360 equals 120n. Okay, that's one way I could get started. The other way that I could have approached this problem is think of this as 120 over 1, and I think about it as cross multiplying. And I get the same result. If I cross multiply, I still get 120n, and I still get 180 times n minus 2. Okay, but just kind of 2 different ways to think about it. Put 120 over 1 and cross multiply, or use inverse operations. I still get here. And so then I would want to subtract 180 from both sides. It would give me negative 360 equals negative what? 120 subtract 180, negative 60n. And then I just have to divide by negative 60. And I get n equals 6. Great, but that doesn't name the polygon. That tells me the number of sides. What polygon has 6 sides? Starts with an H.
Hexagon.
A hexagon, yeah. So from this, I still want to answer the question of, oh, that would be a hexagon. Okay, so make sure we actually name the polygon if we're asked a question like that, where we want to find the number of sides. And honestly, this was the hardest setup. Like, this is the hardest equation to find n from. On the other ones, it's quite a bit easier to find what n is, but I wanted to give you one that's a little more challenging on the review. Okay, so that's notes number 3. And again, I haven't scanned those notes in, so if you haven't watched the video, important to watch it before tomorrow, but I'll also scan the notes in this afternoon. All about finding angle measurements in a polygon. The rest of the unit was all about triangles. So as we transition to this next section, what fact about triangles do we use over and over again, really, throughout the review? What are we going to use here to solve for x? That they equal 180. Yeah, so over and over again, we're using this idea that a triangle equals 180, okay? So if I have 48 and 81 degrees here for the first 2 angles, that's 129 degrees. And then to find this angle, I would just go, okay, well, this angle would be 180 subtract 129, or let's see, 51, right?
Yeah.
51 degrees. So this angle, x plus 63, equals 51 degrees. Okay, so I know my triangle has to total 180, and then I subtract the 63, and I get negative 12. Okay, same idea here. So I go, okay, I have 70 and 55, so that's going to give me 125 degrees between these two angles, which means this angle that's missing here would be 180 subtract 125, or 55 degrees. And then I can solve for x, because 8x minus 1 must equal 55 degrees, or 8x equals 56, and x equals 7. Okay? That idea that the triangle totals 180 we use over and over again here. Flipping your page. Then they get a little trickier, the diagrams. So we're going to use several kind of pieces here that we've used before. There's kind of two ways I could get to x here. First, it gives me this outside angle 115, but what type of angles do I have here? What are these called? Vertical angles. And vertical angles are congruent. So if this is 115, then this angle is 115. Okay. And then I have 115 and 30. So all together between here and here, I have 145 degrees. And then there's two ways I can solve for x. So I'll talk about the second way in a minute. So then using the fact that my triangle adds up to 180, that tells me that this is 35 degrees, this angle. Okay, and so then one way that I can solve for x is going, well, if that's 35, what do I have here? They create a line. So what does that mean? They also have to add up to 180. So I have a linear pair here, which are supplementary or adds up to 180. So if this is 35, this is 145. And then I go 13x plus 15 equals 145. And I'm on my way to solve for x. Okay, so that's one way to do it, is kind of puzzle piece your way through till you get to your angle. The other way that I could have done this is using the exterior angle theorem, which says that this exterior angle adds up to the two remote interior, so the two interior angles that it's not connected to. So you can see if I use that, I would have also gotten 13x plus 15 equals 145. Okay, so I could have used this exterior angle theorem or kind of worked my way through and got my equation that way too. So then I subtract 15 and I get 13x equals 130 and divide by 13 and we get x equals 10. On our diagram in 12, we use some of the same ideas. So again, here we have a linear pair. So what does that mean that inside angle is? If this angle is 80, this angle must be 100 because it has to add up to 180 along that line. And then if I have a 120, I have 120 degrees so far, this angle must be 60 degrees because my triangle has to add up to 180. And if this angle is 60, again, we have another linear pair here. So this must be 120. Okay, so then I know that x plus 122 equals 120, or x equals negative 2. Working through what I have on 13, this time it gives me an angle outside. So if this is 145, the linear pair here would tell me that this inside angle would be 35. Now on this one, I have x in two of my angles. So you may just go from here saying that the first angle plus the second angle, so angle 1 plus angle 2 plus angle 3 has to add up to 180. Okay, so there's my three angles that are within this triangle. And then all together, I have 25 x's. And I have -5 and +35, so 30 equals 180. And now I'm on my way to solve. So I go 25x equals 150 and x equals 6. This is another one I could have used the exterior angle theorem. So this exterior angle adds to these two remote interior angles. That's another way you could have set it up, but you can kind of get there either way. Same idea on 14. I could use the exterior angle theorem, or it's also pretty easy for me to know that this angle must be how many degrees? 50. And then 5x plus 15 plus 6x subtract 6 plus 50 has to add up to 180 within that triangle. Or 11 x's, let's see, 15 take away 6 is 9 plus 59 equals 180. Subtract 59. And 11x equals 121. What's 121 divided by 11? No. 11. 11 times 11 is 121. And again, you'll have a calculator so that the arithmetic piece isn't what trips you up, okay? So that if you, as long as you know your triangle total is 180, you have that resource to help you kind of do the math to get you there. Okay. Then it goes into a section where we are classifying triangles. So that goes back to, I don't have my notes up here. I think the first day of notes where we have kind of a few different cases. So trying to find a good spot to write. I'm going to go over to the side. So there's two words that we want to use. We want to classify it by angles and we want to classify it by sides. So by angles, we have acute, right, or obtuse. I'm just writing some notes here, right? We can use our notes on our assessment. We made this review will be very helpful. Let's put some notes in. So acute means all of the angles are what?
Below 90 degrees.
Less than 90. A right triangle, we have a 90-degree angle, just one. And in an obtuse triangle, we have one angle that is greater than 90 degrees. So this is classifying by angles. We also want to be able to classify by sides. So we have equilateral, which means all of the sides are equal. We have isosceles, which means two sides are equal, and then our third side is something, a different measurement. And we have scalene triangles, which means all three sides are different. And this is classifying by sides. And what we're going to do is we're going to choose one from each category. Okay, so we're going to select one from each category. Okay, to identify what type of triangle we have. So angle, sides, angle, sides, angle, sides. So on our first example, let's start with angle. What type of triangle do we have? Acute, right, or obtuse?
Obtuse.
Obtuse, because of this angle right here. This is an obtuse. Now we choose one from the sides. Is it equilateral, isosceles, or scalene? Isosceles, because these two sides are the same. So this is an obtuse isosceles triangle. Okay, choose one from angles, one from sides. On 16, choose one from the angle description. What type of angles does this triangle have?
Acute.
Acute. And choose one from sides. Isosceles, because these two sides are both 56. It's an acute isosceles triangle. Choose one from angles on 17.
Acute.
Obtuse. And sides.
Isosceles.
Isosceles. That's annoying. Are these all isosceles? No. A lot of them are though. Most are. That's annoying that I did that. On 18, what do I have for angle description?
Right.
Right, that's a right triangle. I have this one right angle, so it's a right. And sides? Scalene. Okay, all three sides are different lengths there, right? Scalene. On 19, what is that?
Acute.
Acute and isosceles. Yep, those two sides are the same. And on 20,
Acute.
obtuse because of this guy. And again, isosceles. Okay. So one from each category, classifying the triangle. Okay, moving on to day 2 of notes. We talked about this. So we have our triangle inequality that says that any two sides always have to add up to be greater than the third side in order for that to be able to form a triangle. And so we're going to look at these three sides and we're going to decide, is it a triangle or can it not be a triangle because it doesn't fit this? This isn't going to be true for it. So I'm going to look at the two smallest sides first, and then if I decide it's not a triangle, I don't have to keep going. So two smallest sides are 2 and 8. Would 2 and 8 add up to be greater than 10?
No.
No, so I just say this is not a triangle. Okay, that doesn't work. 2 and 8 is, that would equal 10, wouldn't be greater than 10. On 22, I have 10 and 12 for my smaller sides. Does that end up being greater than 13? Yeah, and if I'm gonna say it's a triangle, I just want to show that it works from like every direction. Okay, so then 12 and 13 would also be greater than 10, and 10 and 13 would also be greater than 12. It works no matter what two sides I look at, it's always greater than the third. So I'm just, that's kind of like a prove there. Like, look, I checked it all directions, it works. This is a triangle, okay, or could form a triangle. On 23, two smaller sides would be 4 and 6. So 4 and 6 greater than 7, does that work?
Yeah.
Yep. And then 6 and 7 would also be greater than 4, and 4 and 7 would also be greater than 6. It works every way I look at it. This can be a triangle. On 24, two smaller sides, 10 and 8, is that going to be greater than 12? Yep, and 12 and 8 will always be greater than 10, and did I mess it up? 12 and 12, no. Which one am I missing? 10 and 12? 10 and 12 would also always be greater than 8. This one can also be a triangle, okay? So then we use that, and this is the trickier piece here, to decide what are the possible ranges. So there's not just one combo that would work. The angles would change, but there's kind of a range of possible sides that would make the same, it's the same inequality, work. And so to do that, what I do is I like to complete my list. So I have two sides here, and I'm going to add a third side that I'll call X. And if I want this to be a triangle, then same idea. I need the two sides to always be greater than the third side. And I only need to look at this two ways. So one thing I need to consider is that 9 and 12 has to be greater than that third side that I don't know the measure of right now, and I'm going to find the range of. The other inequality that I need to look at would be that 9 plus that side has to be greater than 12. The inequality I don't need to look at is that 12 plus that side has to be greater than 9. That's because 12 is already greater than 9. So I don't need to consider that third inequality to get my range of sides. So looking at the first thing I need to consider, adding those together, that gives me 21 is greater than X, or rewriting that so that my variable comes first. X has to be less than 21. Okay, that's one restriction that I have on that third side. It has to be less than 21 for this to work. And then over here, I'm not just adding, I need to do inverse operations and solve. And I get that X has to be greater than 3. So there's my range, has to be less than 21, greater than 3. Or I could write it together like this. There's my range of sides, okay, that it has to be greater than 3, less than 21. I don't care if you write it separate or together, as long as you have both sides of that range. What does it have to be greater than? What does it have to be less than? And I do want you to rewrite this, because saying 21 is greater than X doesn't make as much sense as saying that X has to be less than 21. Okay, so we want to make sure we're rewriting this side. Same idea on 26, I'm going to have this third side here. So I have 10 plus 8 has to be greater than X. What's the other inequality that I have to consider? X plus what? Which side do I need to look at? X plus 8 or X plus 10?
X plus 8.
X plus 8, because 8's the smaller of those two sides. So I need to make sure that X plus 8 ends up being greater than 10, and I need to make sure that 10 plus 8 ends up being greater than X. So over here I get 18 greater than X, or X has to be less than 18. And over here, subtracting 8 from both sides, I also know that X has to be greater than 2. So I get from 2 to 18. I'm just going to fill out these last two. You can kind of check yourself, because you should have done this for homework. Hopefully we did this for homework. So on 28, I have X is less than 19, and then you should have had X plus 8 has to be greater than 11, or X has to be greater than 3. Those are the two sides of my range. Going back one to 27, 11 and 11. So 11 plus 11 has to be greater than X, or 22 greater than X. X has to be less than 22. Or X has to be greater than 0. Okay, that's your range on 27, 0 to 22. Okay, this is our last piece, right? Yeah. Last thing that we talked about, this was also on the inequality day, is that the length of our sides and the size of our angle measurements are related. So given angles in this triangle on 29, I should be able to order my sides, because my shortest side will be across from my smallest angle. So looking at my angles, because this is my smallest angle, that angle is being formed by the rotation of these two sides, and it's creating this length. So across from my smallest angle is going to be my shortest side. And it asks us to go shortest to longest. So my shortest side is side MK, or KM. My next largest angle is 50. Across from 50 is this side, LK. My largest angle is 92, and across from 92 is ML. Okay, so ordering my sides, given my angles, I'm just matching up smallest angle to shortest side, middle angle to middle length, largest angle to longest side, and it's going across. So what would be my shortest side on 30? It's my shortest side on this triangle. Across from 55 VT, right? Does it matter if I put VT or TV? No, okay, it doesn't matter. It's a segment, so order doesn't matter. What's the middle length? TU. Across from 60 is TU. And my longest length then would be VU or UV. Doesn't matter what direction I go there. So it works, given my angles, I can find my sides, or given my sides, I can order my angles. Oh no, we're not done after this, are we? Oh, I want to talk about then one in class, because you'll see something like it on your test. So I go shortest side is SR, across from that is angle, oops, I was going to write an 8 for some reason, angle Q, okay? So if I have my shortest side, across from that is going to correspond to the smallest angle. My middle length side, which would be 11, would be across from the middle angle measurement. My longest side, 12, would be across from the largest angle in that triangle, which would be angle S. And on 32, what would be my smallest angle? Angle.
Okay.
I would say this is my shortest side.
Oh, yeah.
Yeah. So which angle then would be the smallest? I'm gonna say shortest, smallest is what came out. If 12 is my shortest side, my angle that's smallest would be across from that.
J.
Angle J. Middle angle would be K. Across from the middle side, and then longest side is 28, which is across from angle L. Okay. Okay, so that's our review. We did have you on Friday, you should have completed this in class review. So hopefully you've done that. If you haven't, super valuable to do these problems as well. This one on the back, number 7, I just wanted to talk about real quick because you may see something similar to it. So this is exactly what we were just doing. It says order your sides, but what it didn't give you right away were your angles. It gave you like formulas for your angles or expressions for your angles. And so what you had to do first was go, well, all of these have to add up to 180 and then find X. Now that I know X, I can find my angles. Now I can order my sides. Okay, so it added like a layer of first you got to find your angles. Now that I know my angles, now I can order my sides from smallest to largest. Does that make sense? So it's kind of combining two things that we did. Okay. Okay, let me just points from the parallelogram and uses it. So we're going to start there. So like we said, a quadrilateral is any four-sided polygon. I didn't really talk about what I just passed out, but one is notes. Now the other one is homework, but I put like homework warm-ups, everything in one, just so you didn't have 3 packets going on. So I tried to go by day. So you'll notice like it'll go homework, warm-up, or something like that. So you'll just have to double check that you're not, I'm hoping you don't do a warm-up for homework without looking. Now, when I think of a four-sided polygon, my mind kind of goes here, right? A rectangle, that's what I think about. But there's all sorts of four-sided polygons. Like I could have some odd shaped figure that has 4 sides. It doesn't have to be a rectangle or a square. And in fact, even these guys, where it goes, so this is called a concave polygon. It still has 1, 2, 3, 4 sides. Okay, so we just want to keep in mind that that's a broad statement, is a 4-sided polygon. So we're going to get more specific than that and talk about parallelograms. So parallelograms are types of quadrilaterals, but again, there's all sorts of quadrilaterals out there. with opposite sides congruent. So that's kind of like our rectangle, right? But you can see this isn't quite a rectangle. It's like a rectangle if you like punched it and it leaned over. That's our parallelogram. So like our rectangle, okay, those two sides are the same length. And AB is the same length as DC. Okay, so similar to a rectangle, our opposite sides are congruent or equal to each other. The other thing that makes it a parallelogram is that the opposite sides are parallel. So we already marked opposite sides congruent, meant that AD is congruent to BC, and that AB is congruent to DC. So we already marked that. Opposite sides parallel means that this side is also parallel to this side, that AD is parallel to BC, and that AB is also parallel to DC. Okay, so they are congruent and parallel, same length, running parallel. So things we're going to see with our parallelograms may link back to the parallel lines unit too, right? Alternate interior angles, same side interior angles. Those are going to kind of come back into play because we have parallel lines here. I'm going to give us a few examples of what some problems may look like when we do get to homework. I'm pretty sure, let me double check before I say that I didn't give you any homework tonight other than get ready for your tests, but let me triple check myself. Yeah, no homework tonight. Tomorrow we'll do the first homework on unit 5. Okay, so today's just intro day. Okay. So what something might look like with opposite sides congruent. So here's my example. Maybe we're given x plus 7, 24, 2y plus 1, and 33. So I'll give you a moment to label your diagram the way I have my diagram labeled. Okay, so this is a given. This is given to us that parallelograms, their opposite sides are congruent. So if I was given this diagram and asked to solve for the variables, we're just going to use that thing that's given to us where we know that these two sides are the same length. So that x plus 7 equals 24. Okay, so x must equal 17. We also know that this side is equal to the side opposite at 33. So I know that 2y plus 1 is equal to 33, or 2y equals 32, and y equals 16. Okay, so this is just an example of something we may see. We know this is true now, so that's how we would solve for our variables. Other things that we're going to be told are true about our parallelograms. So this was in our definition, this one was not, okay? Our opposite angles of a parallelogram are congruent. Opposite angles. So what angle do you think is opposite angle C? Or sorry, I just gave it to you. Angle A. C, yeah. What angle would be opposite angle B? D. Okay, the other thing that we are going to learn here is that because these are parallel, okay, these are parallel lines, that these angles are same side interior angles. What did we learn in the parallel line unit that is true about same side interior angles? Are they congruent or supplementary? They are supplementary. So another thing that we actually know, so we know the opposite angles are the same. We also know like these are parallel, these are also parallel across from each other. So these are also same side interior angles, or those are also supplementary. So along with knowing that the angles opposite are congruent, we also know what I'm going to call adjacent angles. Are supplementary. Or we can also think about them as those same side interior angles. Okay, so we also know that that's true. So now I'm going to label my diagram, and we're going to solve for some variables. So if I have x plus 7 for angle A, y for angle B, and 107 for angle C. Well, I know that opposite angles are congruent, which means that x plus 7 has to equal 107. Okay, that's something I know about parallelograms now, that these angles must be the same. So x must equal 100. I also know that adjacent angles are supplementary. So y plus 107 has to equal 180, or y is 180 subtract 107, or y is 73 degrees. Okay, so I know two things. These are the same. These have to add up to 180. Or I could have thought about it that these have to add up to 180. So we're kind of creating a list here of new things that we know. We know that their opposite sides are congruent and parallel. We know that the opposite angles are congruent, and because they're parallel, that the adjacent angles are supplementary. The last property that we talk about with all our quadrilaterals, rectangle, rhombus, square, parallelograms, is we talk about what's called diagonals. So the diagonals mean going from one opposite angle to the other creates a diagonal, and I can also go this way from A to C. Those are my diagonal lengths. The diagonals bisect each other. What does bisect mean?
Like cross.
Well, they're crossing, and while they cross, they will cut into equal parts. Okay, so when I bisect, it means that when I hit here, I'm cutting this length is going to be equal on both sides. And I'm going to cut this length, it's going to be equal on both sides. Then I'm cutting into equal parts. And in fact, 2 equal parts. If I trisected something, I'm cutting it into 3 equal parts. And I'm not going to give us an example here. I'm going to call this x, and so we'll just write a to x must be the same as c to x, that this length is equal to this length, and we use that to set up equations like we did in the first bullet here, and that bx is the same length as dx. All 4 of these are not the same length though, notice, right? So like 2 of them are the same, the other 2 are the same. Only in special parallelograms will it end up being that all of the lengths are the same. So if you flip this, we're just going to look through a couple other examples, and then we're going to leave that there today, and we'll continue to use it tomorrow. So we have a few examples here, the tiny little font. So let me just go through and identify all the variables we need to solve for. So we have A, B, X, Y. Okay, so we have 4 variables that we need to solve for. I'm gonna start with A and B. What do you think A equals? Here's A. What do you think A would be equivalent to? Thoughts? What's true about our parallelogram and their sides? What sides are equal?
6.
Yeah, it's gonna equal 6. Our opposite sides are congruent. So A is here, okay, A must be 6. What must B equal? This is weird labeling. Don't you feel like it should have been 9 there and 6 there? Based on the picture. Doesn't that look longer than this? Maybe not. In my eyes, it does. Okay, so we know our opposite sides are congruent. We now want to find X and Y. Anyone have an idea on what X equals? Here's X. Which angle would X be equal to?
80.
80. Yeah, opposite angles are congruent, so X would equal 80. So the first two, we're using the fact that opposite sides are congruent. To find 80, we know that opposite angles are congruent. Now to find Y, we're using the last piece of this angle info. So we knew opposite angles are congruent and adjacent angles are supplementary. So what would Y equal? If this is 80, then Y must be what if it's supplementary? $80 plus what gives me 180?
100.
100, yeah, they're supplementary. So to find Y, I know that Y is 100 because adjacent angles are supplementary. So these are kind of the pieces we used here to find our missing variables. Then our second example gets all sorts of crazy on us. So here's our second example. A is not so bad. How do I find A, or what would A equal? Here's A.
Well,
A would equal 12. These opposite sides are congruent. So to find A, I'm using opposite sides are congruent. Now B is here. B is on the diagonal. What do you think B would equal? That's the last one we just talked about. Our diagonals bisect each other. So B would be the same length as over here, and that is a 9 and not a G. Okay, so B and 9, that would be the same length. So we know that B is 9 because the diagonals bisect each other. Okay, then I get to X and Y. And so this is adding in a new layer of things we're going to know about our angles. Okay, again, because these are parallel, our parallel line properties still exist. So what we have here, we can use alternate interior angles, which are congruent. So here I have a line, parallel lines here. This is my transversal. If this is 35, then this angle is 35 degrees because they are alternate interior angles. Looking at these parallel lines, same idea to find Y. If this is 45, then this is 45. So Y equals 45 degrees, which we got with alternate interior angles. Now they do kind of a bad job labeling X. For X, it's this whole angle. That's why it's shaded there. So X is not just this piece, it's the whole angle. Now what they're using is that adjacent angles are supplementary or equal 180. The tricky piece here is that this angle is broken up. So what is this entire angle over here? It's broken into 35 and 45, but that means that the entire angle is how many degrees? 35 and 45, 80. So if I know that this is 80 degrees, then the angle that is adjacent to it would have to be how many degrees? 100. Okay, so X is 100 because adjacent angles are supplementary. Okay, so it's really just a preview into parallelogram land. We're gonna write a quick little list. Yeah, we have time. So parallelograms, things we know. We know that the opposite sides are congruent. Opposite angles are congruent. Okay, first two things we know. That the adjacent angles are supplementary or equal 180. We know that opposite sides are parallel, which means we can use parallel line properties, like alternate interior angles and so on. And the last thing we learned was that the diagonals bisect each other. And that the diagonals cut each other in half. So these are the properties we've added today that we'll continue to use tomorrow. Your only homework is to make sure you come prepared for your assessment tomorrow. And we're not really going to do much of a warm up tomorrow. We'll just take our assessment. Okay, any questions? You all know what you're doing for tomorrow? No, you gave me a no at first.
I know you have to clear the question.
No. Oh, that's what your no was? You have no questions? That's good.